Can you see the screen? Okay, so machine learning in search engines. What is machine learning? Machine learning is the branch of artificial intelligence that focuses on using data and algorithms to mimic the way humans learn, with the goal of steadily improving accuracy. Essentially, it is the process of a computer creating an algorithm or using existing algorithms and gradually improving those algorithms as it receives more data. What is machine learning? Sorry, this is a continuation. For example, if you wanted a computer to recognize different breeds of dogs through machine learning, you would give the computer picture of different types of dogs while labeling the characteristics of each picture, such as the tail lengths of each dog or its fur color. As the machine keeps getting more and more pictures of dogs, it will keep tweaking its algorithm so that it can recognize each of the new data. How does it work? A computer is first fed data where the patterns of each data point is clearly labeled by a human beforehand. The computer then tries to make several algorithms that can identify the labeled patterns. Usually, the algorithms don't work in the beginning of the process and they are pretty poorly constructed. But after the first algorithms are built, the computer will check if each algorithm can identify the patterns that were labeled. The best algorithms are kept while the rest are discarded. If the best algorithms still don't work as desired, then the computer will try to create a new set of algorithms that are based on the current best algorithms. This way, as the computer keeps making more and more algorithms, the accuracy incrementally improves because they're best on the best parts of its current algorithms, while it discarded the bad parts, the ones that don't work. And this process keeps repeating until a correct model is found. What are search engines? A search engine is a program or algorithm that searches for specific sets of data by using keywords associated with the desired data. They then present the most relevant data or ordering them from most relevant to least. Some examples are Google, where they use the search engine to search for any kind of data on the internet. Netflix also uses search engines to search for movie titles, actors, and movie categories in their library. How do search engines work? A search engine will first break up each word in a search input. Each of those words and similar words are then used to find pages on the internet where the words are present in each page. For example, if one of the words is dog, then the search algorithm will look through millions of pages that contains the word dog or similar words like puppy, and then it will keep that data on as reference. The engine then tries to cross-reference all the pages for each of the different words to narrow down the search result. Finally, it uses a ranking system to present the data from most relevant to least. Where does machine learning come into play? Most of the problems in searching are simple and can be solved using common algorithms. However, ranking the data based on relevance is a very complex task, since the relevance of the data varies from user to user. Two different people can have different data be different ranks of relevance to them. So this is where AI comes into play. A company can use machine learning to train an AI to sort out the data after a search so that each search is optimized to account for the variability of each user. How does more relevant data help? The more relevant the data is to the user, the more likely it is the type of data the user wanted to search for in the first place. This can reduce the number of links the user has to look through from tens of millions of links to just a couple handful. This is an extremely convenient outcome. For example, if you use Google to search for the word pen, Google's AI would have to try and figure out if you're talking about the writing utensil or the fence or something else. Then it will search through millions of pages in a fraction of a second to find the pages that you are most likely looking for. So what's the catch? Figuring out which data is relevant to a user is a complex process. It requires lots of historical data based on the user and people in the same region or location. Since the AI is predicting the relevance, it will not always be accurate. And this also requires lots of data from the user, which can be personal and a violation of privacy. Since Google's search engine, so a scary outcome is Google's search engine always wants to predict the most relevant data. It will continuously need new data from each of its users to always improve its relevance ranking. This means that it is constantly recording what we do on the internet and then pinning that data to our Google profiles. This can lead to Google having very detailed profiles about millions of people around the world without them even knowing. And this can contain information that the users themselves don't know about themselves. Google Search AI can also predict what you want to search for by recording what you searched on websites outside Google, which means they're buying your data, and more concerningly, other companies are selling your data. How does this make you feel about? So my question to you guys is, how does this make you feel about the future of our privacy? Do you think laws will be established to protect our privacy? And these are my citations.
Okay, thank you very much. That was really
Okay.
good.
This is
So
Anthony's turn.
okay, so after my friend has discussed machine learning and search engines, now I want to talk about machine learning and applications in social media. So next slide. So introduction. So how many of you guys use Facebook, Instagram, Twitter, TikTok, or YouTube? So I'm pretty sure everyone does, right? And this will be an interesting topic. Oh crap! Can you guys hear me?
Yep.
Yeah, very good.
Okay, because I like. So today we're going to talk about the effects of machine learning in our daily lives and how big social media platforms incorporate them. So next slides, please. So now let's look at statistics first. And then there are around 1.65 billion web users that are active in social media, and 96% of the brands out there uses social media. So so what are the things that machine learning uses for, or how does it affect this? Am I still on?
Yep, you're good.
Yeah, man.
You're good.
Yeah, because like, yeah, my thing's froze. It's not responding, the Zoom, so I can't see it. So, okay, I'll just continue. So number one, it improves visual experience. So it is reported that 80% of the Twitter users or watch videos in their platform. And when they do, 90% of them watch it on a handheld screen. So to improve user experience, Twitter decided to buy Magic Pony technology. It is a London-based firm that develops machine learning techniques for visual enhancements. This will help Twitter to automatically sharpen the video and images. Video and live streams are critical for next generation and social media. Number two is kind of more important. It's called marketing. So how many have you guys used the Facebook Marketplace? Myself, that I did fell for one of their directed ads, and more of social media platforms are taking advantage of this and are actually creating a list of or algorithms to create a customized list for each user. Later on the slides, I would explain more about this. And number 3 is data protection. So most of us get spam emails. So imagine being a big social media platform and how much data spam they have and irrelevant data they have. So thankfully, machine learning algorithms are developed to help big social media platforms to clean out irrelevant data. So as a matter of fact, every time you hit spam or violent content or sexual content, you're actually helping the algorithms because you are creating a list of labeled datas. And as like, think about it as a reading. The more you have, the more you read it, the better the algorithm gets. And number 4 is more automation. So next slide, please. So now I want to talk about more about Facebook algorithm. There's a reason why I chose the Facebook algorithm, because the Facebook algorithm has been Facebook has been one of the biggest social media platforms out there, and it's been one of the it's been there for a long time. So therefore, it has a good data set. That means that it is not skewed and it evolves throughout time. So it's a good case study. So what are the things that they look at? So let's look at first, it checks all the available posts, so which is called inventory, the contents that are available, and it all analyzes these factors called signals, which I will talk about later on and get more in depth and actually how they do it. And it predicts how you should react, and it summarizes it into a score. So next slide. So what are the signals that they use? So I believe TikTok also uses this. So actually average time spent on the content. So each Facebook actually knows, like, if you're scrolling up and down and how much like you actually are reading that portion. Overall engagement. This actually has, so when they were programming this in the neural network, so this has more weight. So this takes precedence over a lot of stuff. So that if you, so what are the overall engagement? So this is like person.
Just cut off. Anthony, you still there?
I can't hear it. Hear him?
He has some network issues.
Okay.
Okay. Just give him a second. Safwan, if he might be in the waiting room and you're the host right now, so you should just click it all.
So how do I let him in?
Send the host back to me. Send the I'll reclaim it.
Where do I? How do I do that?
I got it. Don't worry.
Okay.
Yeah, he's back.
Right. Sorry about that. Can you guys still hear me, or
Yeah.
am I back? Okay. What was the last thing that I talked about? Were you guys able to hear?
Signals.
Okay, signal. So I'll just go quickly through them. So average time spent on the content, right? So overall engagement. So what is overall engagement? So this is like person sharing a link on Messenger, commenting or sharing or shared by a friend. So this actually has more weight into the algorithm. So if you guys did a little bit about a program about neural networks, so when they set up the neural networks, this has takes more precedence. So the more people, the more share. It's like grades, right? Not everything is weighted equally. So if more people share it, then you get more points from it. When it is posted, what is the story type and how informative the post is. So one interesting fact that I actually read is that Facebook can actually detect if you're actually doing comment baiting. So comment baiting is like when you put leave a like or please share. Facebook actually gives you negative points for this, which is kind of interesting. And yeah, so next slide. So I want to talk about Facebook's deep text. So what's interesting about this is that the deep text algorithm can actually read between the lines. So they kind of like know such as emotions and sarcasm, and even have predictings like your religion and your like your religion, or if you're depressed and suicidal, which is kind of interesting, just based off text. And as a matter of fact, if you have Facebook, you actually allow them as you allow them to access your private message in Messenger as a database for their machine learning algorithms. So that's one thing you guys have to keep in mind. And is it actually, and if you, and is it okay? Is it ethical for them to like stalk your messages? Next slide, please. And deep face. So deep face is one of the computer vision algorithms they have, and it is facial recognition. So it's quite impressive because it's a natural processing problem, so which is very difficult for computers to do, and it has a 97% accuracy that is almost the same as human error. As a matter of fact, it is better than the FBI technology, which is only around 85%. So Facebook, and one interesting fact is that the reason why this is interesting is because if you tag someone, or uh, if you tag someone, if they see a picture between like you, Facebook can like make friend suggestions, and using this friend suggestions by just looking at like Google Images or like Instagram and all this stuff, they can actually kind of like stalk you in ways, because it's interesting. And actually, and lastly, Facebook use GPS. And if you're like, let's say you're in a party and you open Facebook that day, and another friend also, someone that you know opens Facebook, Facebook might suggest a friend suggestion. Last page, please. So extra content. So if you guys are like find this interesting or like or informative, I would highly suggest that you guys watch The Social Dilemma. It's on Netflix. It's talk about how big data companies and how they sell your data and how they go more in depth about it. And it is a really eye-opener movie, is because machine learning is not really about the algorithms. It's not a race of how efficient the algorithm is. It's about acquisition of data. So when the more data you have, the stronger the program is. And you can actually have a very bad algorithm, but if you have a lot of data, it's most likely it is going to win. And The Social Network by Mark Zuckerberg, and how he created Facebook. So that is it for my presentation.
Okay, thank you very much. That was really good. I'm just gonna reclaim the host and admit. All right, so a few things about your presentation. I found it really informative. It was really good. I like the fact that you guys incorporated questions in between your presentation. That helped me think about it more. Um, in the beginning part, you talked about Google Play listening, and I thought that was really cool because like it can be scary at times. Sometimes I freak out too when I'll be talking to someone about buying something and then ads show up on my phone, on my Instagram and stuff. I find that crazy, that the fact that they're listening to us. Anthony, I like the I when you were talking about signals, you actually learned something new when you said Facebook tracks how much time you spend on reading the content and stuff like that. So I didn't know that. So thank you. That was really good. Anyone have anything else to add?
I actually saw something really interesting about that a couple days ago, where they said it seems like they're listening to you, but what they're doing instead is tracking your location and your friend's location. And if they see something that your friend was buying, um, and then they see that you've been talking to them recently, they'll put that on your list or advertise that to you instead. So it might seem like you were talking to them and then it heard you, but it was more like a lot of information sharing was happening in the background instead, which is a little creepier now that I think about it, but yeah.
Yeah, for sure. And what's crazy to me, I don't know if any one of you followed like the scandal with Cambridge Analytica and Facebook selling data, but the fact that data is such a commodity these days, and there's companies getting sued over it and things like that. I think it's really crazy how 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 unprivate things are these days. As much as we sign like many privacy agreements, I'm curious to see how that really plays out. Sebastian, go ahead and talk.
Yeah, I find it pretty crazy that like they collect so much data and you think that like the data is so irrelevant, but somehow they still want it. Like I don't really care if people know I like cheeseburgers, but apparently they do, so, which I find kind of crazy.
Yeah, Ryan.
Hello.
Yeah, we can hear you.
How do you give feedback to the other presentations? Like, where do we do this?
Okay. So that's gonna be under discussions on Avenue, and you do it in the thread.
Okay, and you just give feedback to each of the different ones, like 50-ish words.
Yeah.
Yeah, it could be feedback or anything like interesting to add, not just
Okay.
yeah.
For now, let's just keep the discussion just to the presentation, and I promise I'm gonna answer everyone's questions later on. Okay.
Okay. Sorry.
No worries. No worries. Ravine, you have your hand up. Go ahead.
Yeah, I also wanted to share something which made me more happier about the privacy that like everything I'm searching on Google. Um, so there's this thing called Privacy Sandbox, and not a lot of browsers use it. I know only Chrome uses it, and it's not like if you search for something, let's say I don't know, like skirts or something, and then the ads for skirts come up. Like it's not gonna be like that. It's more of like what your target audience is, and let's say like all of us are teenagers or something, you know, so like all the things that teenager mostly search, like those things are going to come up. So it wouldn't be individual, it would be more like what your age group is searching. So it kind of makes me feel happy, but yeah, I just wanted to share that too.
Thank you. Yeah, I totally agree. John.
Yeah, well, exactly related to that. I'm almost confident that they still collect the data, they just don't use it because again, it freaks people out. But like the data is worth so much to them that they will collect it. And just to add on to what was said about Google tailoring search results, when using incognito, they still collect data on you. They just don't tailor your search results. So you'll notice sometimes if you want a kind of like a more untailored uh, search query, if you use incognito, it won't be so like related to what you've searched in the past.
Right. Yeah, for sure. Um,
We're just gonna move on because that's 3 minutes already. So we're just gonna
yeah, we're gonna move on just in the interest of time. Those of you I see who have their hands up, thank you for putting your hands up. But we're gonna move on, and then you guys can talk later on after.
the next one. Someone volunteered. It's Felicia and Gary. Are you guys there?
Yep, we're here.
All right.
Yep.
Okay.
Okay.
We okay to start? Good.
Yep,
Yeah.
you ready?
All right. Hi everyone. My name is Jerry, and my partner's name is Felicia, and we will be talking a bit about AI. So, artificial intelligence has had major societal impacts recently that has caused great debate and whether it should be used or pursued as much as it is. In recent years, we have had a great push by government to accelerate artificial intelligence development. Governments are looking at artificial intelligence to help in decision making in society. Next slide, please. Artificial intelligence in the US has had a major push as seen in 2019 by former President Donald Trump. He announced that AI initiative in the US should increase drastically, recommended that federal investment in AI research and development grow by a factor of 10 over the next 10 years. The investment they feel will help organize data, predict outcomes, and manage our world more efficiently and effectively. The use of AI will help make decisions in healthcare, politics, and where streets should be built, and many more areas. Beginning in 2018, The government of Canada and Quebec recognized the importance of international developments. In March 2018, the government of Quebec announced a $5 million grant to set up an international AI organization in Montreal, or to get an AI company to come to the city. The federal government committed to invest up to $10 million over 5 years to support the cause. The total amount of the investment will be up to $15 million over 5 years for Montreal Center of Expertise. Next slide, please. Officially launched in 2020 was the International Center of Expertise in Montreal. The major initiative for the center was how AI can be used to develop technological solutions to better respond to pandemics such as that of the COVID-19. Other major developments of AI at the center will be based on ethical principles, human rights, inclusion, diversity, innovation, and economic growth. AI has immense potential to transform society and provide concrete solutions to the challenges we face today. Next slide, please. Not only have we seen government investment, but a lot more has been invested in Canada. Canada has a thriving AI development with more than 850 startup companies, 20 public research labs, and 60 groups of investors in major hubs such as Montreal, Toronto, Waterloo, Edmonton, and Vancouver. Some examples of companies that have received funding are ADA. ADA, who received $190 million. ADA is an automated customer service experience that provides chatbots used in customer support. Another company that has received funding from Canada is Auto Motors. They have received $70 million to provide self-driving vehicles for safe and efficient material transport inside factories and warehouses. Canada's AI has seen great investment, and over the next 10 years, they predict $16 billion in investment and over 16,000 jobs. Next slide, please. AI has been invested in and has great value as shown to have societal forces, but we have to be careful that the introduction of new technologies and AI are more progressive when it affects social change. And a couple of examples is the self-driving vehicle that has killed a pedestrian before, proving that AI is not the best. Or another example is facial recognition software that does not recognize people of color, which just increases our inequalities in society. To make sure that the investment in AI is for social good, some factors that need to be considered is, first, we need to make sure that there is no manipulation of the technology by those who produce it. Also need to consider the ethical and political issues on why AI is being produced. Next slide, please.
Hey everyone, so now we're going to be jumping into machine learning application to customer service. So the evolution of customer service. This is an interesting one because I'm sure a lot of our generation has grown up living through these changes and has firsthand experience with machine learning in this realm. Customer service in the past can be defined as a provided service most convenient for the company. And what this means is because of how limited streams of instant communication were, consumers could only expect to receive support within retail stores during hours of operation, usually a 9 to 5. Moving forward to customer service in the present and future, we can see the internet and digital technologies take over. Mobile devices and social media platforms are used to connect consumers to service representatives. And even beyond that, we can now see artificial intelligence technologies take over some of the duties humans once had. Customer experience futurist, author, and keynote speaker Blake Morgan created this visual that can further identify the changes machine learning advancements have brought to the service industry. To note a few standouts, we can see technology making the user experience worse to now making it even better. Before the creation of virtual assistants and bots, technology acted as a tedious, unproductive hub where consumers had to wait hours before being connected to a human representative. We can also see changes like a past where companies were in control of interaction versus a future where the consumer is now in control. With the implementation of machine learning, consumers are not confined to a 9-to-5 time slot to seek assistance. They also aren't forced to speak to a human representative if they're not comfortable in doing so. Not only does this allow consumers to easily seek assistance on their own time, they also have options on who or what they choose to seek assistance from. This brings me on to my next point. Machine learning increases self-service solutions. Self-service refers to consumers achieving their service needs through interacting with a human agent. And a human agent is a technology that in a way portrays its own purposes, motivation, and intentions. A few examples of human agents are chatbots and virtual assistants. So chatbots are machine learning to use from the inputs it exercises. In order to understand these inputs, programmers use natural language processing, or NLP, to offer the bot interaction with the human language. An example of a chatbot is the Whole Foods Facebook Messenger bot. Consumers are able to utilize this tool via Facebook Messenger to seek guidance on food types and international cuisines. It is important to note that this bot is an intent-based chatbot, as it prevents the consumer filler words to choose from in their responses based on its familiarity with vocabulary. Intent-based chatbots look for key terms in the messages it receives. Virtual assistants use machine learning to allow them to identify what information they can forward to their consumers. They are powered by a cloud-based AI brain that connects to consumer data via application programming interface, or API. So this graphic goes further into depth on the differences between chatbots and virtual agents. We can see that chatbots are more rule-based and operate on platforms such as websites and support portals, whereas agents can assist in conversation via mobile phones, laptops, and smart speakers. While self-service programs are quite useful, it is important to acknowledge the problem with machine learning in customer service. While this method utilizes voice and language recognition, the coding that goes into traditional voice recognition compromises actual comprehension. And what this means is if a technology is not programmed with every single possible input, even the different variations that a question can be asked in, the bot will be unable to complete its tasks. I'm sure we're all familiar with the common response, "Sorry, I didn't catch that," or "Can you repeat that?" Ultimately, with this barrier in place, these machines will often be unable to serve customers. So fortunately, this brings us to our solution, which is deep learning. Deep learning is the process of removing the linear nature of traditional coding practices and simply allowing the machine to learn for itself. Through this method, we can see the successful recognition of syllables come into play. And through recognizing these syllables, large collections of speech data are now being used and speech patterns are being recognized. This not only ensures customer needs are being understood no matter how the question is being phrased, it also adds a level of inclusivity, as these machines would be able to pick up accents and other language barriers. So there are 3 recognizable benefits that are brought to companies when implementing machine learning. The first is scalability. Companies will expand and will be able to offer a greater reach and quality of this reach to consumers around the world. With that being said, there is also huge benefit to an AI platform's ability to track, collect, and analyze data. It allows companies to understand their consumers in a way where they can make smarter manufacturing and marketing decisions. For example, if a machine identifies a pattern of women in their 30s asking about a certain style of hat, the company can then use this data to advertise this product to that audience. Data collection also brings a level of memory far beyond human capacity, allowing companies to quickly problem solve and prevent problems from even happening to begin with. And there are my references and our question.
So a question that we would like to either just open up to the class or let you guys think about, or we can even just discuss right now is, Do you think with AI becoming more involved in society that people with power will gain more power and have access to other people's lives? Or do you think AI will take away their power? And is there anything that you believe society would want to watch out for and be careful with the advancement of AI? And next slide. And yeah, thank you for listening, and any questions or discussion. Yeah.
Yeah, thank you guys so much. That was really good, super informative. Regarding your question, if there's anything we need to be worried about, I noticed one of you made the point about the self-driving Tesla vehicle crashing. I found that super interesting because usually I'm amazed by these vehicles that can come out of the parking lot and come to the front of the store or whatever. So when I see something like this happen, when the vehicle crashes, it makes you question how safe it really is and whether like you'd feel safe enough to close your eyes and sit back and just relax. So yeah, I think you guys were really good, and I love how you asked this question. Anybody else have anything to add? You answer the question.
Yeah, can I speak?
Yeah, go ahead.
Yeah, regarding like the question and like the first part of the presentation, I think like one interesting like use case of this would be how AI could help could play a role in like politics in terms of helping politicians or government officials learn more about citizens. And I think that this has a really interesting effect in the future in terms of how it could affect like politics, perhaps affect like voting patterns and how politicians approach like campaign strategies. So I think that's kind of like a scary prospect of how AI could be used in a government situation. However, I also think that it could also be used in um, a great situation where AI could be used to help governments make smarter investing decisions, or just better decisions in general. For example, perhaps machine learning algorithms could be used to predict like the spread of possible diseases that could help us in a pandemic like situation, predicting which areas would become hotspots and based on current trends, and and allow politicians to adapt so based on the decisions made by these algorithms.
Yeah, for sure.
Yeah, so Calvin, I mean, I just spoke, so I 100% agree with that. But where I was also coming from is like with AI, like you gotta think, well, what I was thinking, like Google, right? Google kind of is like AI almost, and it persuades you to think what they're thinking, right? So if you search up something and the answer comes up, you're persuaded that that will be the answer. So that's where I was coming from, where the worry of like I'm saying, people in power like Google, the people running Google, the top people, right? They could convince you or convince anyone that something is right, even though it may not be right, like 100% right, if you get what I'm trying to say. Like when I'm saying people with power will gain more power, is that's what I kind of meant by the question.
Yeah, I see. I think that like going off that could also, I think it's really hard and perhaps like inevitable that these instances where big companies could influence people's decisions will have like political bias to it, and I think that that's a really like dangerous um that could lead to like some really dangerous outcomes depending on how wide how many people this affects.
David, do you want to jump in real quick?
Oh, I had something different to say, but just to finish this conversation or to continue this conversation, like I think that big business and all that is already doing this stuff, even without AI. Like they already through lobbying and stuff do convince us, and like lobbying marketing, they do kind of convince us what we think and what we don't think. So in that way, I totally see AI as being just like another tool that they can use. But I do wonder if it'll actually change anything, or if it just extends the power they have. And then the other thing I was just going to say was, I think that AI can also give people power. And I was thinking like people with disabilities and like virtual assistants, and the ability to like they can pick their own music and stuff now just by talking to their phone in ways that before, like putting on a song would have been an impossible task for someone that didn't have use of their hands, or someone that didn't have like good dexterity. So like different like, from arthritis, like cerebral palsy and stuff. So I think there's a lot of really cool stuff with disability in AI, and it can empower those people to have more control over their lives.
Yeah, for sure. I totally agree.
We're gonna take
The
just
last,
one more, and then we're gonna
yeah,
off
one more.
discussion. Yeah, please.
So, Karthik, do you want to go?
Yeah, hi, can you hear me?
Yeah, I can hear you.
Yeah, so I feel that AI can be used by public transportation because it will not only make it more optimized, but it will also, help people to reach their destinations faster. Like in Germany, if we see, they're using AI actually to control the traffic light system. So not like in most of the countries they use sensors to change the car, to give you a green light or something. But in countries like Germany, they actually use AI to detect the number of cars on the road, and in that way, the signals change. So that's pretty interesting.
Yeah, that's super interesting. I like that point. So we are gonna move on in the interest of time. I do see everyone's hands. Thank you so much for contributing to the discussion. Just makes the class a whole lot better. But we are gonna move on to our third group.
We have volunteers. It's Isha and Elham. I pronounced that right.
Yeah, give me the host, please, because I
You,
have the
you have
PowerPoint.
screen sharing abilities, so you can just go ahead and share your screen.
Oh, okay. All right. All right. Hello, everyone. My name's Elham, and together with my partner Isha, we'll be talking about AI in our daily lives. So what is AI? In basic terms, it's humanity's attempt at mimicking human intelligence. This can range from simple algorithms to complex neural networks that are loosely modeled after our own brains. AI has come a long way and is growing exponentially. It's starting to integrate into our daily lives through personalized ads, facial recognition, self-driving cars, virtual assistants, and many more applications. We can only expect this trend to keep growing. Therefore, we must prepare ourselves for a future run by smart machines.
So something you may wonder is how and why exactly do machines learn? As an example, say that we were given 10 photos of mammals and had to classify each photo as either depicting a person or a horse. For most of us, that would be a relatively easy task. We can look at a photo and without putting any thought into it, very quickly determine whether it's an animal or a person. However, if we were given a very large set of photos, maybe upwards of a couple 100,000, classifying them would become an extremely time-consuming and tedious task. Luckily for us, computers are an amazing invention that help us automate tedious and time-consuming tasks while conserving human power. Unfortunately, computers don't have brains, and therefore a simple task such as classifying humans and horses would be almost impossible for a computer to do on its own. However, the power of machine learning allows us to combine a human's ability to think and a computer's computational power to maximize the efficiency of these kinds of tasks. Essentially, a human will train the computer on how to classify mammals, and the computer will be able to then do it on its own. So the way machines are taught can be broken down into a number of steps. The first step is to gather training data. In our example, this means we want to define the traits that we use to classify animals and humans and create a training set. Despite being able to easily classify horses and people in our daily life, if you do think about it, there are many qualities that differentiate the two, as well as many exceptions. In the interest of simplicity, let's say that we differentiate them based on whether they have hooves or whether they have hands. To create a training set using this information, we will select a sample of photos from the total data set, determine which of the traits are present in each photo, and manually classify each one based on those traits. The idea is that the machine will study this training set similar to how you may study notes for a test, to try and understand the concept that is being taught. In this case, the concept is how to differentiate horses from people by understanding the correlation of each species and each trait. This leads us to the next step, which is data preparation. We want to prepare the data in such a way such as to reduce or eliminate any biases as well as to randomize the data.
It is very important to randomize the data to ensure that the machine is not simply memorizing the chronological order of the data, as opposed to actually learning how to classify people and horses. This is similar to preventing a student from memorizing exam content instead of actually understanding and applying it. It's also important to reduce biases. An example of a bias in the data would be if majority of the photos were human and a small amount were horses. This would incorrectly teach the machine that human is usually the right answer, and so when given a random input, it will most likely guess human, while disregarding the traits. Finally, we want to reserve a portion of the training set to be the evaluation set. This will be used to test the performance of the machine once it has been trained on the remaining data. In many machine learning models, we work with numerical datasets. In those cases, we may also need to normalize the data. Next, we need to choose a model. A model is a mathematical function that relates the input, output, and condition variables. The input in this case would be a photo of either a horse or a human. The condition variables would represent the traits we want the machine to use to analyze the photo. The output is the category that the machine decides to classify the photo as. Although we're not working with numerical data in this example, the model can still be represented with mathematical variables in various ways. For example, by using binary indicators. It would be incredibly difficult to derive a model function by ourselves, but luckily, there are many popular models that have already been devised and are used in real machine learning. Some examples of these functions are the sigmoid function and the linear function. Once we have chosen a model, it's time to train the model. This is the most important step of the process and understandably the most complex step. In fact, there is an entire branch of software engineering, computer science, and data science pertaining to training models. Once the code has been developed in a language such as MATLAB or Python, the process in simplest terms consists of initializing random values, running the model, and then repeatedly running the model in order to give the machine more practice. If done correctly, the results should become increasingly more accurate with each repetition. And now that the model has been trained, we need to test or evaluate its performance. If you recall, at the data preparation step, a smaller portion of the data set was reserved as the evaluation set. The machine was not exposed to these photos during the training. Therefore, it will need to apply what it has learned in order to classify them. This is once again analogous to a student who has studied practice questions, but now must solve brand new questions on the exam. This step will let us know whether the machine has properly trained and correctly learned how to classify humans and horses. The machine is given the evaluation set of photos as input, and the output is observed. If the machine delivers the output with the desired accuracy, we can safely assume that it will now be able to classify any photo that we provide to it. We can now leave the computer to classify the hundreds of thousands of photos we need to classify and spend that valuable time doing something else. Although this is an extremely simplified overview of the machine learning process, it still helps us realize the power of machine learning. Training computers to think like humans results in a wide range of applications and possible changes to our daily lives. In fact, in this current age of technology, we are exposed to more examples of machine learning every day than you may realize. Some of these applications are present in search engines, social media, and video games. Now we will explore some applications of machine learning in our daily lives.
So one place where you could have come across AI is, of course, video games through computer-controlled players. So there are many applications in AI in popular games today, like Pac-Man, Halo, Rocket League, and one of the most classic games I'm sure everyone is familiar with is online chess. This was incredibly popular and in fact built into most computers starting in the early 2000s. When playing chess against a computer opponent, you're actually playing against AI that has been taught through machine learning to play chess. In fact, once a computer is trained, it is not vulnerable to human faults such as stress, slow reaction time, or distractions. It will quickly analyze the board and the next best move to make every time, therefore making it a very worthy opponent and better than most recreational chess players. One very interesting example of a chess playing computer is Deep Blue, which was developed by IBM in 1989. IBM asked Thomas Anantaraman and Murray Campbell to build a machine that could win against a national chess champion. The machine was initially called Deep Thought, but was eventually renamed Deep Blue. On February 10th, 1996, Deep Blue played against the world chess champion Garry Kasparov, losing or tying each match. A rematch was held in 1997, and this time the machine won, making it the first machine in the world to beat a world champion in a match. This was a monumental milestone in the development of AI because it revealed the power that AI holds when given the ability to think like a human. IBM has since then become a leader in AI development and deep learning. Since then, many more games with higher quality graphics have been developed with AI to provide a very engaging form of recreation. Not all forms of AI in video games are machine-learned opponents. Many games have scripted AI or non-player characters which enhance the gaming experience for players. Millions of people across the world enjoy playing these video games often, and they have become a staple in many people's daily lives. One of the most significant impacts AI has made in our daily lives is in its applications in social media. We may not know it or notice it, but AI is being constantly used by social media platforms. For example, Facebook utilizes machine learning to do a multitude of things, from recommending you friends and pages, recognizing your face, and serving you personalized ads. And a more specific example with Facebook is that it allegedly used the 10 years ago trend, a popular fad that involved users posting a picture from 10 years ago and one from the present, to train their facial recognition algorithms on age progression and age recognition. This is definitely not a far-fetched allegation, as the huge data set of millions of posts from the trend would have been extremely valuable for Facebook. This is because it would enable them to recognize how people age, and with that understanding, they would be able to more precisely target people with ads and recommendations, potentially increasing impression numbers. Is this sort of application harmful? Maybe, maybe not. It all depends on how this technology is regulated and used. One thing we can be certain of is that this is inevitable and the technology will keep advancing. So we must equip ourselves now to help humanity ease into the future. Search engines are another thing that we use daily, and most, if not all, people take it for granted. One way search engines use AI is for quality control. Before the implementation of AI, many search engine optimization specialists use shady tactics in order for their content to be the first few to show up in the search results. These are practices such as invisible text, tag stuffing, cloaking, among other things. This resulted in low-quality spam showing up in the top results, which damaged search engines. Now they've updated their algorithms and use AI to regulate which pages are the most relevant. Another use of AI in search engines is creating ranking algorithms. This is where AI is trained to learn how to rank search results. They're taught to create an optimized list from a set of possible results, and they learn from the variations over time. As an example, the AI might notice that a result is ranked fifth, that a result ranked fifth might be receiving much more clicks than the others, which is when the AI will bump it up to make a more convenient experience for the user. Finally, one more significant use of AI in search engines is natural language processing, or NLP, which is a branch of AI dedicated to understanding human language. A study from the University of Washington looked at the fourth leading search engine, Yandex, where they saw that developers used data from users' previous searches to optimize future results. This resulted in an increase in their click-through rate by 10%. Thank you for listening, and do you have any questions? These are sources. Yeah.
Thank you. That was really good. Does anyone have anything to add to that? So to start off, I will say that point where you were talking about Deep Blue versus Garry Kasparov, when I took this course, that's what I actually did my presentation on. It was like a big part of it. And I find that really interesting. I think that was like a major step for mankind to be able to actually have a machine beat a world chess champion. So yeah, I think that was really cool. And I did a little bit of research on that when I presented on it. And yeah, I think it's super interesting how IBM were able to actually like tinker with it after they lost initially and then come back and beat them after. So yeah, I
Yeah,
think that was
absolutely. I think that also demonstrated the importance of AI, and maybe it sparked some acceleration in its development.
and I feel like it shows what we can do.
Yeah,
If
yeah, absolutely.
if we can beat the best, then there's amazing things we can do with AI. Anyone else have anything to add?
Yeah, I have a small point to add about like how AI is used in search engines.
Yeah.
I think it's really interesting that I read from an article that when you make like typos or when you make typos and you create a search query, it actually helps and improves Google's machine learning system in its search engine because it's adding to the data model of possible words that associates it to what you're probably like searching for. So I think that like that's a really important and useful feature that when more and more people make like these like small typos or even like misspell a bunch of search terms, it actually improves um, Google's ability to figure out what you're trying to search.
Mhm. Yeah, for sure. That's a great point. Also adding on, I love how you guys are debating and talking about things regarding the presentation in the chat. That's really cool. Please keep doing that. And also one more thing I know I didn't mention it in the beginning, but if you could just use the raise your hand function before you talk. I know I said call up, but I didn't really realize how many people are going to be like discussing. So if you could just raise your hand and then I'll call on you to talk. But yeah, anyone else have anything else to add? No? Okay, let's move on to the next one. Our son, who's going next?
It's group 5. It's Goresh and Sebastian.
Okay. Thank you again, Isha and Ilham.
Yep. There we are. Can you guys hear me?
Yeah.
Yeah.
Okay. There's the slide. Yep. Yeah, we can start.
Can everyone see the screen?
Yep.
Yep.
All right. All right. So hey everyone, my name's Sebastian, and my partner Virash will be talking to you about the basics of machine learning in search engines. So a search engine is something that we've all used before, whether it's Google, Bing, or Netflix. It's pretty amazing how a few words can be used to filter through trillions of web content to give you results that are relevant to your search. But trying to understand the entirety of search engine optimization is impossible, but it can be broken down into some main functional components. And these components are query understanding, search ranking, and content understanding.
Okay, so I'll just go into a bit of details for these topics. Like as mentioned, like previous groups have already talked about it, so I'll maybe go into details more. So the first part is query understanding. This is the basic step. So if I type something in Google search, how does the computer understand what I'm typing? This is very important for the computer to be able to understand your search query so that it can find results and rank them later. So query understanding, the first step you would do is tokenize these sentences. This is something we do as humans where we break up our sentences into words to understand them. Computers need to do this too, because for computers, breaking them up into smaller components is very important because these will be later used in other models. So how do you break up sentences? You could use white space, you could use punctuations, you could use commas. This just depends on the heuristics you choose, and different results you can have different results based on what you choose to do. So now that you have broken up your words into tokens, what do? The next step is feeding this into the natural language processing models. Other groups have briefly touched about this. Basically, this is just a model that takes in, let's say, words as input, and this would output you some classes related to the words. It doesn't necessarily have to be classes. It could be probabilities of which class it could belong to. So now we feed in our words, we get our classes. Let's say I typed in what is soccer, that could be related to sports. These classes are important because we'll use them later on when I'll explain how these classes will be used to figure out what you're trying to search. So now we have our classes, we tokenized everything. Now there's something called the spelling correction. Calvin talked about it during the discussion session. It's trying to fix your typos and also using these typos to train your model better. So how do we figure out typos? So how do we do it is we give probabilities for each words in the sentences. Let's say the word going in this picture. We could give that this word belongs here with like 90% probability. If it's very low percentage, we know this word should not belong in this sentence. That means there was a typo or we missed the word somewhere. And Google can use that to fix the query you're typing and then give you the results you wanted. We've all done this at some point where we just did a typo in Google search, but we still got the thing we were looking for. And it also said we're searching for this instead. This is because there's spelling correction going on in the background, and this is what like allows you to have accurate results even if you make big mistakes in your search query. Now, another part is query rewriting. So these can be broken down into query expansion and relaxation. So what is query expansion? Like we've all been there where we're typing some question, why is something something, and it will suggest more, words to add in there. It's doing this because if you just type why is, that's not enough information to narrow down which websites you want to go to. So that's why search engines will give you the options to choose which query you want to choose. Like in that picture where I just type why is, and then it's trying to expand that query. The next part is query relaxation. Sometimes, let's say you're in software and then you copy paste your code in like the Google search. Your code might be too specific and you don't get any results. So what the search engine can do is remove words from your search query so that you get some kind of results. So which words do you remove? That can be chosen by the search engine. You can mix and match removing words so that you get better results for whatever search query you input. Now that we're done with query understanding, the next thing is search ranking. So query understanding, the computer knows what we type. So I found some results. How do we rank it? We all use the first page of Google. We never go to second page. But how does Google like rank it so that the first few links are very relevant to what we search? These are determined through some factors. The main factor would be relevance of web page. If I have cat in my question, what is a cat? Obviously, you would choose websites that have cat in them to display. That's the most basic part. But there's also the problem where if you have cats, or like if you have a different word that has synonyms, how do you figure out how words are related to each other? So we also need to figure out the relationship between words. And this is where natural language processing models are very helpful to figure out relationships and trying to tie in websites that belong to the same thing. So now the next part of it is also the quality of the content. If you search something, the first few links are, excluding the ads, are usually like valid website. They're not like scam website or like fake information. It's like usually like dictionary or Wikipedia. So that means that the search engines are prioritizing websites that are legitimate, like are reliable. So how does it do it? So this is done through something called page ranking. In the background, web pages are ranked based on their reliability. So that you don't go to scam websites or you don't click on fake information. They're trying to do this on purpose because it is dangerous to let people click on scam website and stuff. How does this most simplest way you could like figure out if a website is reliable is just see if the website is being linked from another reliable website. Let's say I go to New York Times and they link to some other website. Most likely that website is trustworthy. So that's one trick. And there's also more things you can do. And that's the question I want you guys to think about. How do you detect scam website or fake information? How does your email know that you have like this is a scam email? There's like a various machine learning algorithms you could use too. This is something you guys can think about and put in the discussion thread. Or yeah, you can also expand my knowledge on it. And the last part of search ranking is context and personalization. If I type in Walmart, I'm going to get the Walmart near my house because I have geolocation data on. So that means the search engine knows how to use my personal data to give me results that are very like relevant to me. you they also use not only personal data, also past search history data. So the other day I searched up SLAM, like SLAM. SLAM is like a generic word, but SLAM is also a software algorithm for localization and mapping. But when I searched it up, the first result was the algorithm, not the verb SLAM or anything else. How did the search engine know? It knew because I'm a software student, so I usually type in like software related stuff. So that's why it knew that I want content related to that. So now we're done through query understanding, search ranking, and the last one is content understanding. So this is about understanding the website you're displaying. The search engine also needs to understand the websites too, not just your query and rank them. It needs to know what's in the website. How does it do it? So these can be broken down into techniques. The first one is page classification. You remember how I talked about classes with the search query where we break them up into tokens and figure out the classes, like what is soccer, it can be the sports category. So we can do the same thing for the pages. We can just feed the text in the pages, like take all the text, feed it into a natural language processing model, and then get the classes related. So let's say I feed in like a sports website. In there, I would get the classes, maybe news and sports. Now you see where we go. We just combine these through. We go for the queries, we get the classes there. We go for the pages, we get the classes there, and we see with the similarity. And using that, you can get relevant results. Another thing that exists we use for content understanding is entity relationship detection. In websites, you usually have images and you have text, you have other content in there. How do you know what the relationship between the image and the text is? Because if you do Google image search and you type in cat, it gives you the image of a cat, not let's say not anything else. But let's say in the same web page where you found the image of the cat, there was an image of a dog. But how did it? But the word cat was mentioned in the web page. How did it differentiate which image to pick to show you when you Google image searched a cat? That's done through this relationship. Basically, there are machine learning models trying to figure out the relationship between a specific image and a specific text in specific websites so that when you search for things, these relationships are kept in mind. The last one is sentiment analysis. This is like modern techniques used in search engines. One of the uh, important things about this is subjectivity and objectivity classification. If I type in a question like, what is a cat? I don't want subjective answers in Reddit or like some other forums telling me what a cat is. I want like the dictionary answer or like a Wikipedia link. So that means the search engine needs to be able to identify what a subjective answer is and what objective answer is, so that for a subjective question, you can give a subjective answer, and for an objective question, you can give an objective answer. That's all the three main components. I think there's more components like search filters and etc. And you guys can Google search these and try to figure out and talk about them in the discussion thread, because I want to know about more components too, because these are like very basic and I think they are the main components. But yeah, if you guys find more components that you think search engines need to have or use currently, you should like talk about them in the discussion thread. And with that, I'll pass it to my teammate to talk about like how companies have their search engine differently than how they have better search engines and what kind of algorithms they use.
All right, thanks, Virash. Yeah, so now that you understand kind of the basics of how AI is implemented into search engines, I'm just going to talk about a few examples, a few algorithms that Google uses to better their search experience for their users. Now, I won't go too in depth into the algorithm since Google does not publish public information on that, but I'll show you how they're able to improve the search experience so that it's better for everyone. All right, so the first algorithm I'm going to talk about, next slide, please. Yep, thank you. It's called the Panda algorithm. It was developed in 2011 because many companies were actually ranking higher on the search results even though they produced low quality and irrelevant content. And these companies were called content farms. And what they would do were publish large amounts of low quality content, market them on social media, and then pay a lot for their ad campaigns so they can get a lot of traffic. But then Google noticed this and they developed something called quality classification, which was an AI-enabled algorithm that separated low-quality content to high-quality content, so allowing websites with higher quality and more relevant content to rank higher than those like fake websites. Moving on to the next algorithm, something called the penguin algorithm, similar to the panda algorithm to kind of combat against black hat SEO techniques. In this case, it was to counter link building techniques, which is a strategy where a lot of low quality links are used in their web pages to gain higher search ranking. They used something called pattern recognition, where they were able to kind of see the web pages and what kind of web pages are using low quality links and what kinds are using better quality links, and kind of ranking them based on that. And the final algorithm I want to talk that Google uses is the hummingbird algorithm. It uses semantic search and natural language processing. Like Viraj said before, how sometimes you might have typos when you search. It works very similar to that and infers the intent of your search and kind of gets the result that I was expecting. So even if you type something wrong or what you type in the search bar was not really what you wanted it to mean, the results will still show what you expected, or at least close to what you expected. This just means that Google search is able to parse the intent rather than the exact keyword that you put in. So it makes it for a better user experience. So moving on to Netflix. Netflix is a bit different from most search engines. It's actually called a recommendation engine because usually people don't always search movie titles on Netflix. They just kind of click it on their homepage. So these are some of the recommendation metrics that Netflix uses to determine what they want to show on your homepage. They use watch time, what kind of movies you like, genres, how many actors that are in it, or which actor that you watch the most. And they kind of rank this in rows and rankings. Next slide, please. Yep. So on the homepage, they categorize the first 3 rows, and you have the first row with first row will be like the most relevant, and then maybe it'll be something else that you like. So as you scroll down, it'll become less and less relevant than what you wanted it to be. And another way they personalize your homepage is with thumbnails. If you look at someone else's homepage, and let's say you have all the same movies on the homepage, your thumbnails will all completely be different. Let's say you like a particular actor in a certain movie. For that movie, it will show a thumbnail of that actor that you like. And let's say another person likes the same movie, but they enjoy explosions in that movie. That thumbnail on that movie might be an explosion. So it categorizes and personalizes each thumbnail to what you enjoy. And that's it for our presentation. I hope you learned a little bit more about search engine and AI. And and our references are here if you want any more additional information. Thanks.
Yeah, thank you so much. That was a really interesting presentation, really informative. Does anyone have anything to add to that?
Click on these links, by the way. They explain it better than I did. So.
Anyone? Well, I really found it interesting when you talked about how Google actually ranks the websites that are shown, especially when you talked about reliability and stuff like that. I actually didn't know any of that. So that was really cool to learn. Thanks for that. Anybody else want to add anything?
I also wanted to appreciate the presentation. I'm probably not going to look at Google like I used to before this presentation. One thing I also learned last year, that how do you include or exclude words to just like narrow down your search, which you also talked about. So like if you don't want to search something, if you want to search something but not want to include a word, you can just say like cats, not dogs, and it's going to show all the websites that have the cat but not the dog. Or if you want to see like cats and dogs, you can just search like cats and dogs, so it's going to show like pictures with both of them. So yeah, it's quite interesting actually.
Kind of want to add on to that, but I don't know if it's just me, but I've noticed in like the past couple of years, those Boolean terms and stuff like and not don't seem to work as well as they used to. Like I'll search cats and dogs, and then I'll search cats, not dogs, and what'll happen is like I can get sometimes the same websites popping up in both searches, and it's a bit strange.
Okay, just real quick, they don't really use like the and or, they kind of use symbols instead, but that's it.
Oh, that's interesting.
Karthik, last one.
Yeah, and since you mentioned about the SEO, I wanted to also like talk about the cool stuff about the SEO. Like I read somewhere that 75% of the website is just the SEO. Like it doesn't consist what is going to be there on the website, and just 25% is on the website. So like sometimes when you search on Google or something, you can find the keywords just below the link, but when you actually open the link, those words won't be there. So 75% is off the website actually. That's SEO.
Yeah, guys, thank you again for that presentation. That was great points, great discussions. Right now we're at the halfway point, so we're gonna do a 10-minute break. I'm gonna pause the recording, and I'll see you guys back here at 7:39 or 7:40. And continuing from there, our son will pick up and he'll conduct the rest. So I'll see you guys soon. All right, hey everyone, we're back. Just before I hand it off to our son, I just want to say we want to get through all the presentations today. So at the end of class, if it's before 9, great. But even if it's after 9, we'll stay back a couple minutes to answer all your questions because I know there were still some questions left. So just be patient. We'll answer them all at the end. All right, son, I'm gonna make you the host right now, and then we can continue.
Okay.
Yeah, you got it.
All right. So the next group is Edmund and Alex. You guys here?
Yep. I'm here.
Yeah.
Alright. Can you guys see my screen?
Yeah.
Just let me know when we can start.
Right now.
Okay. Hi guys, my name is Ahmed Usmani.
And I'm Alex Jablonski.
And today our presentation is about how machine learning is applied into smartphones. So machine learning is a process that is derived from artificial intelligence. The main objective of this technology is for a machine to be able to collect large amounts of data and then process it on its own. The process for machine learning is that a machine analyzes large amounts of old or past data to find patterns within it. Once these patterns are identified, they can be used to predict how future data will behave. And in applications that require it, machine learning can be used to increase the accuracy if the goal is to reduce the margin of error. Machine learning is so far providing users with a lot of benefits compared to the drawbacks, which is why it is becoming so popular. And an interesting fact is that according to Statista, 31.8 million Canadians use smartphones, and approximately 65% of all smartphones in the world are already using machine learning. So it's pretty safe to say that this is a very well established and a technology that's improving with time. So a little bit on the background of machine learning. In the 1950s, that was a period where we began to see artificial intelligence being developed. And then with time, we also started to see a branch technology called machine learning. During the 1970s and 80s is when we started to see machine learning and AI sort of split into their own specific branches. And this happened because the focus of both technologies started to change. Machine learning started to focus more on neural networks, which are the algorithms that basically mimic the way that the human brain operates and perceives data. Around the early 2000s is when we began to see the development of a new branch, which was based on machine learning, and this is called deep learning. This is a more advanced version of machine learning, and as it gathers more complex and layered information from the data provided. And so far, this looks to be the future of data science.
So machine learning is applied in smartphones in various different ways. Some examples include analyzing user inputs and behaviors. This means that machines, more specifically the smartphone, can recognize patterns in your behavior and cater to the user's
cater the user experience to what they would like. So it notices things that you frequently search for or functions you frequently use, and then make those functions more easily accessible. And those searches show up in your recommendations. So video recommendations or folders with frequently used apps are both examples of ways that smartphones do this. Next, there's image, speech, and text recognition. Smartphones use machine learning to scan images and gather meaning from both speech and text. Using data collected from this learning, they can perform various functions. For example, things like editing photos, using filters, and searching for things using the voice function. Next slide. Yeah. There are many examples of machine learning in smartphones. Some of these include improved picture and video quality, which uses image recognition technology to artificially enhance, sharpen, and improve the focus of lower quality photos, sometimes even while the picture is being taken with certain devices. Next, there's facial recognition, which is a form of protection for your device to only allow the user into the phone and block anyone else from entering. This technology is very advanced and cannot be fooled with pictures of the user or closed eyes if someone were to try and get into the phone while you're sleeping. There is also augmented reality technology, which allows users to put the phone into a headset and enter a virtual reality. This augmented reality function can be used for many different things like gaming and simulations. Another example is autocorrect or autofill. This function is used when typing. The AI can detect a mistake and try to fix it instantly to the word it thinks you're trying to write. Machine learning often recognizes words you use more often and begins to autofill it when it recognizes that you are trying to write that word. This function is sometimes not the most accurate, but it is apparent that with every update, it gets better and better. And finally, voice assistants. Voice assistants use speech recognition technology to follow directions and fulfill tasks that the user requests. There are many examples of these, which include Siri, Alexa, and many more. Every manufacturer seems to have their own virtual assistant.
So some of the benefits of applying machine learning in smartphones. So applying machine learning has given a lot of benefits to smartphone users, and this is kind of why so many tech companies are starting to implement it in their products and focus heavily on this technology. One of the benefits of machine learning is that it is used to improve the user experience on a phone and to sort of tailor or customize the experience to that user. This makes the phone a lot more easier and convenient to use. An example of this is the suggested apps on an iPhone when you swipe down. These are the apps that machine learning predicts that you want to use when you open your phone by seeing what apps have the most screen time and are being opened the most when you're using your phone. Another benefit of machine learning is privacy. Since machine learning is done locally within the device, the user data is not transferred anywhere for analysis. Therefore, the chances for a privacy concern are very low. This actually leads to another benefit, which is reduced latency. Latency is the time taken between when a user inputs an action and the corresponding result appearing on the screen. Since, again, the data is being handled internally and there's no external data transfer, the phone becomes much more responsive and snappy due to the lower latency times. Another benefit is that installation of machine learning is not very expensive compared to other technologies. And this is a benefit and the reason why even smaller companies are starting to introduce this technology in their phones. There are a few drawbacks of machine learning and like adding them into a smartphone. Running machine learning, just like any other process in a phone, requires energy. And this naturally takes a toll on the battery life of a device. And this is evident in newer smartphones which come out year by year. And we see that the size of the battery does increase with each phone, but the battery life itself, we don't see groundbreaking improvements. Machine learning itself is a process to reduce errors by examining past data. However, there is a very small chance that a major error occurs. Major error is when machine learning is unable to predict or respond in a situation, and this normally happens when there is an unexpected situation, such as an outlier in a data set. Since machine learning runs on algorithms, there is a chance that the data is not within the parameters set as the technology was being set up, and this could potentially disrupt the process that is trying to run. Another issue that arises due to implementing machine learning in smartphones is increased prices. Companies often love to advertise and show off the new cutting edge features they put into their phones. And this is normally achieved due to machine learning, and naturally, this does drive up the prices of the product.
So, in conclusion, machine learning has been and is becoming a given standard in the technology world, specifically with smartphones. Any phone you can buy most likely uses machine learning. And users are now more often interacting more and more with machine learning without even knowing it, because it makes tasks on smartphones significantly easier and more convenient. This machine learning technology is constantly being developed in a safe and cost-effective manner, which is why so many people are embracing it. Machine learning makes the smartphone experience significantly better, and with advanced engineering done at these companies, there are very little risks when it comes to using this technology. I'd now like to leave off with a thinking question for the audience, which would be, do you think smartphones would be as popular if there was no machine learning technology involved? Thank you.
All right, thank you guys. It was very well done. The pace was good as well. It was well structured and well prepared. So one thing I want to say that you talked to us, it's not to the question, but it's to deep learning. I just reminded of me, is that I think back in 2017, Google's DeepMind AlphaGo beat the world's best player in Go. So Go is a game. It's like chess, but it's like a little bit different. So Alpha's Google DeepMind beat him in 2017, and that was like seen as like the biggest thing in AI that it has surpassed its capability. So that was kind of controversial as well. So I think that was very interesting.
Actually, I haven't heard about that example, but I have seen other ones where deep learning is kind of like machine learning is probably like the basic level, but deep learning is what they're focusing for in the future.
Yeah, that's cool. Does anybody else want to say something or add anything?
I think when he was talking about like the potential for major errors, that was really interesting, and it kind of applies to AlphaGo as well. Because I remember the documentary saying that I watched saying AlphaGo actually failed on its big day against one of the major chess players. It won, I think, 6 of its matches. I don't know if it was 5 or 6, but it messed up on the last one, and it wasn't because it under strategized or something like that, but rather that there was an error in the code, and that caused a cascading set of errors, and so that was kind of interesting.
AlphaGo doesn't play chess.
Yeah.
It was Go, the game, the Chinese one, right?
Yeah, you said it played chess, but yeah.
Brain fart.
Yeah. Anybody else? All right, so since none, we'll move on. The next group is group 4, Alex and Andy. You guys know?
Hey.
Yeah.
So you guys see my screen?
Yeah.
Okay. Andy?
You can start whenever you're ready.
Okay, one second. I'm just making sure Andy's here.
Yeah, just give me 1 second. Can you guys hear me?
Yeah. Yeah, just go ahead and start off.
All right. Hello, everyone. My name is Andy, and today Alex and I will discuss machine learning in self-driving cars and its implication for the future. So next slide, please. So first of all, what are self-driving cars? So can you guys type in the chat the first thing that comes to your mind when you think of self-driving cars? And you can also raise your hand if you have heard of them.
Yes.
All right, thanks for your participation. We'll just move on. So yeah, so self-driving cars or autonomous vehicle uses AI and GPS and sensor to perceive the surroundings and to drive itself without the intervention of a human operator. And machine learning is used to train the car through driving simulators, data gathering, and human intervention. So as you can see the car on the right, Waymo is a company owned by Google, and it has 20 million miles driven during the training process. And you can see the cameras on top and all the sensors on the side around it. And we'll talk more in a bit. Next slide, please. And here, this is a Tesla neural network. So so you guys know Tesla as a company known for electric car and self-driving cars. So this is what is shown when a neural network is processing. And so the data and inputs are gathered using multiple sensors and the cameras around the car. The bird eye view network takes the video from all cameras to output the road layout, static infrastructure like parking cars, and the 3D objects directly in the top-down view. So from the lecture, we know that the computer vision is being used here to identify objects such as cars, pedestrians, and the intersection. And then it projects the distance from them. It also identifies the lane, the road conditions, and the stop sign, and it also issues a warning. So next slide, please. Now that we know the basics of machine learning in self-driving cars, we then question if self-driving cars are good or bad for society. We will use the SWOT analysis to talk about the strengths, weaknesses, opportunities, and threats about AI in self-driving car. So first of all, we will analyze the strengths. Next slide, please. They help with the safer transportation for the impaired or people with disabilities. It also eliminates the pressure from processing a lot of input at the same time. It could be overwhelming for new drivers. And since 90% of road crashes are caused by human error or condition, so the algorithm can help remove that and reduce that. And moreover, it cannot use alcohol or other substances that humans are subject to impairment. And then the next part is the sensor plays a major role in improving the driving experience by providing a better awareness and mapping out trajectory as seen on the right. And lastly, it is more eco-friendly since most self-driving cars use electricity, and it is also a luxury, as you do not see a lot of Tesla on the street yet. So next slide. However, it's not flawless. So we do have some weaknesses for the system. Next slide, please. So even though the cheapest Tesla model only costs around $8 for a full charge, it costs about 37,000 USD upfront and an addition of $10,000 for the full self-driving capability. So because due to the research and the technology for it, it also induced more driving and living further away from the destination because you can do a lot more things while the car drives itself. And the second weakness is training time. As seen on the right, it takes a lot of training time and a lot of data gathering for it to drive itself. And even with all of that, like the 70,000 GPU hours, it still haven't covered all the scenarios that a driver can encounter during their drive home. And the last and probably most important weakness is ethical decision making. It cannot, since it's an algorithm, it cannot make all the ethical decisions for us. And so there's a dilemma on, say, the train track, and you choose to say hit one person or hit 4 person, and of course, like the car would stop. But say if it can't stop, then who would you hit? So it could be applied to this problem too. So Germany actually attempt to solve this by providing a guideline that a self-driving car should minimize human deaths and shouldn't discriminate between individuals based on age, gender, or any other factors. And of course, the AI should always put human lives on top of animals or other equipment or priorities. All right, so those are strengths and weaknesses, and Alex will talk about the opportunities and the threats.
Okay, so essentially for opportunities, I sort of just kind of brought it together into 5 general topics, starting with business and manufacturing. So essentially, we're going to see this transition towards ride sharing. No, we ultimately think it's going to be the dominant method of transportation, as manufacturing in general usually becomes more efficient and prices for transportation decrease. So it's kind of like this substitution effort. So if continuing on to that point, you can look at it like cars will remain parked for the majority of their lives because people are moving towards that ride sharing initiative. And then ultimately those autonomous vehicles will be driving more than those parked cars, which auto manufacturers will adjust their production numbers to accommodate. So as I said, you just want to look at it from a substitution angle, right? You want to substitute those gas-powered, sometimes electric, but mostly gas-powered vehicles. They're outdated, they're going to remain parked. And then as you have self-driving coming in, people will ultimately notice just how much better in general it is to sort of, you don't necessarily have to take command of the wheel all the time. You just have something drive for you. So kind of further expanding on that kind of point, eventually we're going to look into changes to the overall ownership paradigm. So if you don't have to own a car because you have some car driving for you at a few clicks to your smartphone, you have somebody pick you up, nobody's driving, it's just the car is right in front of your doorstep. Ultimately, people are going to just slowly want to get away from that ownership perspective and move more towards this kind of pay as you go service. Think of it like Uber, but without even the Uber driver. It's just a whole fleet of cars just driving themselves all around town nonstop. Sorry, one sec. Okay. And then the next set of opportunities is mostly within the growth of cities. So in general, you'll see buildings and parking lots will start to be decoupled, and that will leave more room for that valuable land development. So think of it like in places of Toronto, a lot of people are desperate to find parking around the city. I mean, you're paying like $20 just to park your car temporarily. There's a lot of discouraging factors when it comes to actually driving a car in the city, and a lot of people understand that if you do live in places like Toronto. So you're going to see a shift in commuting technology, which will decrease that need for that parking locally, but you're also going to see that marginal decrease in the need for parking space. So that space will eventually turn into the idea to develop areas located in those parking structures or designated parking spaces. And then moving on to emissions control. If you guys have paid attention to self-driving cars, think of it like your Tesla. I mean, they're almost all electric. It seems like the foundation to self-driving cars will be electric vehicles. So, we think that you're going to incorporate more electric cars into the standard specification, reducing carbon emissions. And you see a lot of governments backing this kind of initiative with their own sort of public policies that already encourage those electric vehicles, and then just go ahead and throw on the self-driving cars and the machine learning algorithms as sort of that complement that sort of thing. And then eventually, of course, your central charging stations, accommodating that automated transportation. Okay, so moving on to threats. So obviously, as of right now, the AI or the machine learning algorithms aren't capable of training the cars absolutely perfectly, okay? As Andy had said, we're talking about 20 million miles put on Waymo, and they're still not legally allowed to be driving in California all the time. So I even saw some comments in the chat earlier, basically saying, we're going to have fully autonomous cars by 2029. That honestly, it's almost impossible to have that case. I mean, we need like millions, tens of millions of more miles just to get these things to make sure they can stay on the road. And if you can even find like videos on YouTube, let's say, of Tesla autopilot, almost hitting a barrier or something. So ultimately, they need like just a massive amounts of information to actually drive. And like I said, they're just not trained as much as they should be. So if you really want to look at it from a privacy protections perspective as well, there's concerns around having your location tracked based on your transportation history, and just all that sort of things just collected by your vehicle manufacturers just to resell online, right? So a lot of people are skeptical just about Facebook, or just looking at Instagram or Google, and people are saying, look, I don't want you knowing all this different private information of mine. Think about when they're solely going to be figuring out where you are at all times, if they're not already doing it already. And then moving towards the misuse of technology, anything can get hacked. There has to be loopholes in any sort of software system. You can even hear about that story in the US of that major oil company or a gas manufacturer being hacked, and they stalled up I think the gas distribution in places like Miami or something for like almost a week. So think about that from hacking self-driving cars. I mean, the possibilities to do malicious purposes are the possibilities for malicious purposes. They're not really realized yet, and we're never really going to know what they are until people actually start getting their cars hacked or even worse. And then my personal opinion, the special interests. We're talking about oil companies, non-electric car manufacturers, sometimes even municipal transportation. Like your subway station, or not your subway station, but more like your busing and your trucking and that sort of thing. These are multi-trillion-dollar industries, especially the oil companies. They don't want to see electric cars on the road. And once you convince them that you're going to have autonomous electric cars, and everyone thinks they're absolutely amazing, you're going to have people with a lot of money and a lot of power sort of advocating for something like that not to happen. Sort of moving on to a little bit more. So, I mean, even if you look at the picture on the left right there, those are two trucks that could be transporting anything, maybe gas, maybe some sort of like some kind of like chemical or something. Picture a scenario of that with a self-driving autonomous truck, and they're just moving in fleets simultaneously together, very long distances. So we're looking at industry disruptors at this point. So, or sorry, that's more with eliminating jobs. So, transportation disruptions and trucking, and just a little statistic for you guys to keep into consideration. The Employment and Social Development Canada document suggests over 600,000 more jobs were at risk, including parking attendants, auto body repair workers, even some police and emergency workers, just from eliminating these transportation jobs, right? It's just posed for extreme industry disruptions. And just to look at three separate industries, we can consider insurance. So reducing auto accidents as the AI and these machine learning algorithms become nearly perfect. You can also look at it from travel hotels. So people will ultimately choose to just sleep in the back of let's say their Model T Tesla, while it's on autopilot between two major cities while they're on vacation, instead of sleeping at like a motel or something like that. And then ultimately, like how I discussed earlier, that energy and that petroleum problem. Less cars on the road just means less demand for that gas. So overall, I think me and Andy are pretty optimistic about autonomous vehicles. We think they are a really great innovative achievement. And you can put it into perspective, like people were thinking the exact same ideas during 2 centuries of machine industrialization, right? They're thinking all these new machines that are making our economy sort of like hyper efficient, they're just going to kill massive amounts of jobs, and we're going to have like extreme poverty or something like that. Obviously, the exact opposite happened. I mean, there really isn't a better time to be living than right now in like places like America, places like Canada, Europe. So ultimately, this is just the next stage, right? The next stage is just more advanced machinery, and we think they're going to create hundreds of thousands, if not millions, of more jobs. Even considering places like Tesla, or companies like Tesla, and the millions of workers they had to hire to run those mega factories, building their autonomous vehicles. So yeah, just a question to kind of open up some conversation. What do you guys think about autonomous vehicles? Thank you.
Does anybody want to answer that, or?
Sure, I'll add to that. When we talked about the strengths, I know it was touched upon, but the eco-friendliness, just the fact that these algorithms can, besides like auto driving, they can optimize for like better, like they're not fuel consumption, they don't consume fuel, but just better better mileage. They can they can design algorithms and kind of just drive better, like brake slower and accelerate slower and just drive more consistently, and it's just better for the environment. And maybe that's not touched upon enough.
Yeah. So Andy, you can go next.
Yeah, so kind of want to touch on that. So the paper I was reading on the eco-friendly part of self-driven cars. So they said it either could help reduce fuel usage by 90% or increase it by to 50%. So like you said, right, there are two faces of the coin, and then I kind of mentioned the second one in like inducing more driving. Like usually when you're driving, you tend to choose the shortest path to save fuel, right? But unless there's like congestion or anything. So for self-driving cars, you have more free time technically, so you're more like likely to choose like let whatever the car wants to do, and you can live further because you have more space on you can just do whatever on the car. And yeah, so the paper was really like, I think it was 2015, and yeah, so like either reduced by 9% or increased by 250%. So there's it's still up in the air.
Yeah, that's very interesting. Calvin?
Yeah, I think there's definitely a lot of positive outlook for a more widespread integration of self-driving cars, particularly because if you extrapolate like the data, even though it's a small data set, comparing like the safety rate of self-driving cars to just like like normal cars that humans drive, right? Like there's way more accidents adjusted to the same percentage for human driven cars compared to self-driven cars. I also think that obviously like Tesla is the pioneer for self-driving cars. I think that looking at Tesla and what they're doing is also a definitive like indicator of where self-driving cars are heading. Like I understand that on one of their like news models, like Elon Musk said that that the news model won't even have like gear shifters and turn signals. Like the car would just like guess the direction based on like maps and whatever the context of the situation is, and that it will like reverse or step on the brakes depending on depending on the driving conditions, which is really interesting, but also like pretty scary at the same time.
Yeah, because like if it gets in an accident, who would be responsible, right? So
yeah,
that's very So Anthony, you want to add anything?
Yeah, I was wondering, like, what's like for the most people around here, like, there's level of autonomous with self-driving cars. I was wondering, like, what do you guys think about like what level should be? I believe Tesla's around level 3 or 4, and level 5 is like taking up the steering wheel. So like if we do get there, so I was wondering, like, for the people that present, so what level of autonomous do you want to give power to the AI for the cars?
I guess I'll just answer that. Ultimately, these things need to be perfect. So whatever the highest level it is, we're going to reach that phase no matter what. I mean, as you continuously retrain these models, they're going to drive better than human beings. They're going to make better decisions. In the presentation, I had mentioned that like human beings, without like at an unconscious sort of like conditioned level, we just process road information like it's nothing, right? It's second nature to us. We're all like 20 years old, so even just driving for 5 years, we adapted to driving every single day for hours. So these algorithms, they're going to train these computers to think just like humans, and they're going to train them to drive just like humans. and then eventually they're not going to make the mistakes that humans make. And my personal opinion is like that's obviously better for society. If we're going to be substituting these cars when people realize that, you know, autonomous driving is definitely the way to go, they're going to want to make sure their product is like bulletproof pretty much. So whatever the highest level it is, if you want to call it 3, if you want to call it 5, you know, steering wheel, no steering wheel, they're going to, and I think that's obviously the best way to go.
Okay,
I
thanks,
think
man.
I think when it comes to like autonomous driving and how much power, how much AI you give it, I think there's always this understanding that humans always want control over something, right? And if you take that away completely, people tend to get really uncomfortable with the entire idea of AI. Like no matter what system we make, no matter however we design it, we always have an emergency stop button on it. So I think with autonomous driving, if we want the AI to control the whole car, okay, fine. But like when it comes down to it, if I want control of my car back, I want control of my car back, right? So
yeah,
that's just my take.
Maha, you're right about that. You can actually take control of your Tesla autopilot. If you've seen videos on YouTube, kind of shows, or whoever has a Tesla, if you're driving on autopilot and it's making like a wrong decision, it automatically shuts off as soon as you put your hand on it and just kind of jerk a movement back into like putting it into order. I think just like anything, it's going to be a natural progression towards like full autonomy. Like we're going to get used to it over time. That's just like what I think is going to happen.
All right, thank you guys for the presentation. It was very well done. One thing I would say, it was very creative for you guys to use a SWOT analysis. So that was very good. We're going to move on because we don't have enough time. And the next group is Adam and Eamon. You guys here?
Yep, I'm here.
All right.
Let me just share my screen. Okay, you can see the screen, right?
Yeah.
All right.
Hi guys, so this is our presentation on reflection number 2. Next slide. And this is the prompt. Next slide. Okay, so as AI research develops and becomes more applicable in our everyday lives, it, like any field of science, will be intertwined with broader societal implications. Today we'll be discussing examples such as politics and governance, IBM's Deep Blue project, and Amazon's recruitment algorithms, to specifically look at the ethical and societal concerns of AI research as it can and was applied in these instances. Next slide. Okay, so to start, let's look at the relation between governance and AI research. Governments have the responsibility to base and implement laws based on scientific jurisdiction. This can range from simple health guidelines to emergency efforts as seen in the battle against COVID-19. As AI becomes more accessible, governments will fund and take interest in AI research for it to become more applicable in our everyday lives. While this is great, possible issues of authenticity can arise. Such an example is an incident, as you can see the article on the screen, involving an IBM researcher at a Cambridge University who saw his name being misused and referenced in a research paper he had no part in. The report was funded by several governments, and it can be seen how there is incompetency from governance to authenticate this report and those who wish to profit off these government-backed initiatives by writing such false papers, showing that whenever there is money involved, it is difficult to isolate and conduct pure research due to mismanagement from various parties involved. If anything, it can be argued that the monetization of AI research, as seen with the incident with the IBM researcher, will in a sense commodify this sector for business of independent employers in order to lift responsibility on the governance of the state. So for example, any accusations brought against authorities in false AI research, such as lawsuits, for example, will be put on the smaller parties instead. Next slide. So in terms of politics, it will be very possible that there will be politicization of AI for propaganda uses. For example, core notes in Indian AI research has been used to help in translation issues backed politically by programs such as Digital India. And if you go on the next slide. So as you can see on the screen, AI programs such as AI Revolution and the National Language Translation Mission are backed by parties in power to provide young people with various opportunities. There is much return to this type of advocacy, and it is also a form of soft power for various political parties. So it is essentially like a poster example of what if the party in power or was majority in government can offer the general population. Next slide. Now, while this is a positive initiative, CORE also notes the possibility of spread of misinformation surrounding AI on social media, specifically relating to the negative effects of security and privacy concerns. With the pandemic, it can clearly be seen how certain policies involving COVID have been used to raise suspicions in people as propaganda tools to sway voters to either parties. So it is very possible that this can lead to an influx of AI research reports made with confirmation bias. So essentially that means making research reports that instead of looking at the issue objectively are made with a certain interest in mind and used for political gain disguised as science initiatives, which further demonstrates the difficulty of presenting unbiased research when funded by parties for varying interests. Now, with all of that said, do any of you believe that it is possible to create such a system where AI and politics will be independent of each other? And if so, what would that look like? For example, what rules could be implemented to do so? And I guess you could answer that right now in the chat instead. Anyway, next slide.
All right. Now for the third topic of discussion, I would like to expand on the way AI and AI research has been intertwined with broader social forces such as game playing. Many advances have been made in the way modern scientific research is conducted today. However, the extent of what is being researched points me in the direction that it cannot be isolated from its social implications. A familiar and very famous example of game playing AI we've all seen from week 1 of the course is IBM's AI system known as Deep Blue. For those of you who may have forgotten, IBM developed Deep Blue in 1989 with the sole purpose of defeating the world champion chess player and to be awarded the Fredkin Prize. This prize was awarded to the scientist able to develop an AI system capable of defeating a champion chess player. After years of research and developing the proper technology required for the task, an astounding victory was achieved by Deep Blue in 1997 in defeating Kasparov, who was the world champion at the time. An astonishing feat seen by thousands. This was a major achievement as countless other AI systems were developed to claim the prize, but none of them were successful in a full victory. This created a turning point, not only for AI research, but also for bystanders watching this on TV, as more fuel was thrown into the everlasting flame, which was the debate of man versus machine. There's no doubt in my mind that at this time, individuals must have been excited, but also concerned for what the future can hold with this newly achieved milestone. The importance of game playing AI was shown in its full capacity, as it encouraged scientists to persevere in new areas of AI research that was never done before, and it demonstrates our willingness to compete. By outperforming a human in a very convoluted task such as chess, Deep Blue challenged our understanding of what we define as intelligent, whilst also demonstrating the ever-apparent progress towards artificial general intelligence, AGI. But at the same time, the social implications lead us to wonder how this technological advancement can be applied in the future, rather than viewing it as an all-purpose game-playing machine. Now that we have some background on how AI has been intertwined with game playing, I'd like to ask the audience, what social implications do you think arose while conducting this AI research on IBM's Deep Blue? For instance, how do you think society was involved, the communities affected, and so on? Maybe we could go to this at the end of the presentation and give people time to think. I believe that it is very difficult for scientific research to be completely isolated from its social implications. No matter how small the research may seem, there are always going to be parties affected. Deep Blue is an excellent example of how scientific research does not have to be the most groundbreaking for it to have social implications. At the time, headlines were made all over as people cheered on, wondering who would win in this thrilling battle between AI and humans. This made it difficult to avoid social implications as so many eyes were watching the results of years of scientific research. Many questions would be on people's minds, such as, if AI was able to outclass the world champion in a game of chess, what other activities could AI outperform humans in? Or in the distant future, will jobs be replaced with AI? And lastly, how will our everyday lives be affected by the integration of AI technology? And to end this topic of game playing AI, I'd like to share a quote from one of the developers of Deep Blue that really emphasizes the way people were viewing AI at the time and demonstrates the social impact it had. So the quote reads, "Some people are apprehensive about what the future can bring, but it's important to remember that a computer is a tool. The fact that a computer won is not a bad thing." I think this really emphasizes the possible concerns going on at the time with this competition. For the last topic of discussion, I'd like to talk about the way AI research has been intertwined with employment and what other social implications have occurred because of it. So the application of sorting algorithms is not a new one with the advances of AI technology today. Many large companies use algorithms that we interact with on a day-to-day basis, such as Google, YouTube, and Facebook. However, is AI really able to nullify any bias that may occur within these algorithms? In 2014, Amazon launched its very own automated recruiting tool process to review job applicants' resumes and determine if they could be a possible candidate for the job. With help of over 10 years of historical data gathered from humans, it seemed as though the AI recruitment tool was fully trained to pick up applicants with high degree of accuracy. However, the historical data was flawed and it developed a bias against women and eventually stopped being used. An interesting fact, as seen on the right, is that over the 10-year period of human selection data, the AI noticed that there was a 60% employment rate of men at Amazon's technical roles and began developing what is known as AI bias. Despite fixing the gender bias in the algorithm, the program was ultimately scrapped as it was difficult to pinpoint what other bias the AI may have developed over the 10 years of flawed data. I believe at the time where large companies are beginning to use AI technology more and more, it was imperative for Amazon to begin developing its very own algorithm. I can imagine early scientists developing second wave AI did not expect the technology to be used prematurely without first determining potential flaws in collecting data. This would ultimately paint AI in bad lighting socially and would leave an everlasting effect on individuals questioning if AI was truly ready to be used. Relating this to a more recent example we've seen this week with the ImageNet dataset we read about, we already know how much time and effort went into developing a strong dataset, which can take up to years to develop. But it's also a matter of the quality of the information being given in order to create a strong AI and avoid any potential bias. AI research is a tremendous part of the future ahead of us. The involvement of money in politics raises concerns as how pure and isolated research can ever be done. Early advancements in AI research, such as IBM's Deep Blue, demonstrates the many social implications that come with success. On the contrary, shortcomings like Amazon's automated recruitment tool indicate that we have a lot to learn before a world where AI functions more as colleagues than as tools is born. Thanks for listening.
All right, thanks for the presentation. It was very well done again. I really like how you connected the presentation to the course material. And also you mentioned ImageNet. One thing I want to say about that is something around ImageNet is going to be in your quiz as well. So do look out for that as well. And yes.
Oh, okay. Yeah, I found ImageNet really interesting to see how much effort was required in order to get that data set and like the way people think in order to minimize the amount of times it takes. Like I think earlier they guessed it would take like 90 years to get to their goal, but eventually they figured out a workaround and to minimize that time, which I thought was really cool.
Yeah. Yep. Okay, so I think we are pressed for time, so we're just gonna move on to the next one. It's Anthony and Arik.
Our last group, right?
Yeah.
So then we can have questions.
So yeah, just one thing. My group member didn't like he's not here. He didn't participate, so I'm just presenting solo.
No worries.
able to see? Oh. There we go. Okay, is it good now?
It's good now.
Yep. All right. So my presentation is on AI analysis and social media. Right. So we're going to be with the potential of social media analysis and what it can do. So in recent years, there have been a lot of efforts made by organizations to analyze trends in social media to determine what some users think or feel with regards to certain topics. By better understanding how people behave on social media, organizations have been able to better understand the human audiences that they wish to target and have become better at doing so. You've almost certainly seen the products of this research when you find your YouTube recommended feed being populated by videos that are suited to your tastes, or ads on Instagram or Reddit that relate to items that you recently posted about. In this regard, social media has proven itself to be one of the best vehicles for gauging public sentiments and tendencies, as it displays a strong connection to real-world behaviors. The way that we behave online bears many similarities to how we behave face-to-face, or at least hints at the personalities of the users. There's also no shortage of relevant data to be analyzed, since it is dynamic in nature and constantly being updated. This dynamic trait also ensures that data doesn't become redundant over time, meaning that there's always going to be some relevant information to be analyzed that reflects modern trends. With so much rich data constantly available for analysis, there's almost no limit to the potential of technologies looking to analyze how humans behave. Even with the narrow capabilities of today's technologies, much of which has been supported by AI efforts, an unsettling amount of information is able to be inferred about how we behave online. In the future, an even deeper understanding might be gathered of individuals who post online. Political opinions, consumer preferences, and personal decision-making factors may all be sought after by organizations capable of thoroughly analyzing social media. But it isn't all great. There are some challenges in social media analysis that still need to be tackled. With such a large quantity of information constantly being uploaded to social media, properly analyzing the data goes beyond human abilities, and even some computers will struggle to analyze the information in its entirety and must instead examine small samples. But even with this reduction in size, systems meant to analyze data from social media still struggle in the process and must be designed with a trade-off between quality of data and immediacy. The main issue is that the data lacks rigorous structure that computers are used to handling. There are often inaccuracies in the information provided and sometimes contradictions or inconsistencies. Additionally, social media is mainly used for communicating subjective information, such as opinions and perspectives. This type of information is known to be much more difficult for computers to understand and analyze than traditional objective data. The information being shared through social media is ultimately meant for humans and not computers. For a computer to properly analyze social media communications, it would have to be able to very quickly sort through large quantities of data, understand the intentions of all authors despite their errors and variability, and relate this information to other groups of authors with similar interests, classifying how they behave as their own unique group. With millions of authors and likely thousands of unique groups, which they themselves need to be analyzed, it becomes clear that computers are facing a Goliath task. So the role in AI in tackling this challenge. There's been substantial promise from AI technologies in being able to successfully analyze information from social media. Most major organizations are already using the technology, which is responsible for that abundance of targeted advertising that's seen today. A key advantage that AI has over standard data handling methods is that it's able to continuously improve at finding abstract relationships with the assistance of machine learning. Machine learning is useful when finding hidden connections and identifying patterns because it allows the computer to learn from past mistakes and adjust its methods accordingly. So as long as feedback is being continuously provided to AI, it will gradually become faster and more accurate at understanding and analyzing data from social media. Without AI involvement, computers are limited by the ability of humans to identify relationships in social media. So in terms of how they do it, we're going to be talking about the AI analysis methods. So several methods are employed by AI to classify relationships and analyze data collected from social media. The first would be to analyze temporal data. So the study of collections of documents having timestamps or other temporal information is known as temporal information retrieval. AI frequently employ this method when they are classifying groups of data based on what time they were delivered. Not only is it important for AI to be able to classify groups of data based on their associated timestamps, the manner in which these groups of data develop over time is also relevant during analyses. For example, a keyword such as earthquake might spike for a week and quickly decline with natural disaster coverage, whereas the name of a prime minister may spike leading up to an election, but remain higher than usual until the end of their term. Being able to differentiate groups of data for how they behave with respect to time is an integral part of analysis for some AI. It allows them to employ techniques such as story segmentation, topic detection, and new event detection, which can enrich a set of data. Another way they classify or they handle things is by using events and sub-events. AI often classifies sudden bursts of activity on social media as events, with the smaller internal spikes associated with this activity being called sub-events. There are usually two classifications of events that occur on social media. Exogenous, meaning that the source of the event is something that happens in the real world, and endogenous, meaning that the event originates from something that happened online. So this could be like a Twitter hashtag or something. Depending on the purpose of the AI, they can be designed to recognize and ignore certain types of events if they are not relevant to its analyses. They may also choose to forego the classification altogether and observe all events without distinction. Critical to most event analyses, however, are the sub-events which complement main events. For example, if a natural disaster were to occur, social media would immediately report on the event. In addition to this main event, there would also be smaller sub-events outlining what buildings were damaged, where victims might be trapped, or who was injured. These sub-events in social media are crucial for providing a complete analysis of the situation, which proves their importance. While this is a general example, and the real value of sub-events would lie in more subtle observations, it conveys that an analysis is made more useful when they are observed. Another method that AIs use is classification and clustering-based methods. As is to be expected from social media, there are many posts that are redundant and add very little information to an AI's analysis. They either serve to express an idea which is commonplace on the platform, or do little to impact the frequency at which the idea is brought up. For cases like these, considerable processing power can be saved by ignoring the data and not considering its candidacy for belonging to a unique event. Classification methods describe those methods which deal with the quantity of data being examined. Whenever there's a spike in the frequency of this otherwise redundant data, a new event is reported. For example, if the term like bread becomes suddenly a widespread internet expression, that's certainly cause for the creation of a new event, even though nothing has changed with the expression itself. A common benchmark for reporting events when they change in frequency would be like set a threshold for like units of standard deviation and compare that to previous mentions for the topic. Clustering methods describe those methods which deal with the uniqueness of data being observed. Every time a new data entry is observed, it's compared to a set of existing event clusters. If the data is similar enough to an existing cluster, it's added to it, and if it's not, a new cluster is created. In addition to these methods, AI need to have some way of evaluating the events that they detect. So when dealing with AI using machine learning, it may take time before usable analyses can be produced. This is because the AI must be trained to understand what results it's meant to be observing, learning from the past mistakes that it makes. A standard method for performing this evaluation is in terms of sensitivity and false discovery rate. Sensitivity refers to the fraction of events that are detected. For example, if there are 5 events produced in a set of data, and the AI only detects 3, the sensitivity would be 60%. The false discovery rate refers to the fraction of event reports that don't actually respond to events or correspond to events. If the AI were to report 3 events and one of them didn't correspond to any actual event, then the false discovery rate would be 33%. More examples were provided in the slide. So as you can see in the image, there are certain events which miss and certain ones which hit. Typically, when the sensitivity is higher, there's more attempts to determine events, but you're also going to come into cases where there's a lot more false discovery events. So again, higher sensitivities usually mean that the system is more likely to falsely report events, and therefore there is a trade-off to be weighed for those designing the AI. In some cases, it's more important for all events to be detected, regardless of the number of false events, while in others, the cost of falsely reporting might be higher than the benefit of actually reporting every event. So I'll take a little break and put a little question out there to say, what are some ways that AI could be used in social media to benefit society? And is there any way for AI to benefit society? There are some out there who might say that there is no way that it can benefit everyone. So we can think about that, but we'll come back to that at the end as well. So I've already provided one example, which I think is pretty relevant, which is AI and emergency response for looking through social media. So one area where AI could be a clear benefit in analyzing social media is in emergency response. Major events are reported much more quickly on social media than on standard news outlets. In the 2013 Westgate shooting, attacks were reported on social media within 1 minute of the attack beginning, beating mainstream media by 30 minutes. Additionally, social media provides far more information regarding an emergency than mainstream media ever could. During a major earthquake, there will be thousands of individuals reporting the locations of the injured, providing damage assessments, and participating in crisis communication. In the past, emergency response agencies have made calls to humanitarian organizations to manually sift through this data sent to social media in order to receive this additional information. This method is very inefficient, however, as there's often information overload during a crisis. Fortunately, AI have been able to assist with this information processing in recent years as the technology has developed to better handle and classify information from social media. Using the previously discussed methods of ignoring redundant information and classifying events and sub-events, AI may be able to save thousands of lives and drastically improve our ability to respond to emergencies. So the future of AI on social media. As AI continues to improve at understanding human communication and analyzing social media, it will surely be used with greater frequency to meet the demands of large organizations. While some of these organizations may attempt to use the technology with good intentions, such as humanitarian organizations or emergency response agencies like I discussed, others may use the technology to manipulate society. As corporations and politicians invest more into AI analysis, we may see the technology achieve some frightening capabilities. Once AI become better at determining what impulses drive society to behave in certain ways and begin to abuse this knowledge for the gain of a select few, there will surely be questions about the ethics of AI interference in social media and the individual's right to free will. Additionally, with more corporations attempting to access social media data, there may also be questions regarding privacy and how much personal data can be legally collected. It's important that the public is aware of the dangers of AI and advocates for proper legal protections as the technology advances. So, the discussion statement that I'd like to leave off on. In 2014, an AI simulating a 13-year-old Ukrainian boy was able to pass the Turing test, fooling more than 1/3 of the human judges into thinking its messages were from a human. So the Turing test was developed by Alan Turing, and it's kind of like a benchmark for judging whether or not a machine can be said to truly mimic a human or have artificial intelligence. So for the first time ever, we're starting to have AI that can do the job well enough to fool a lot of people. So this is obviously could cause problems on places like Twitter or Reddit, where there's a lot of bots that could be sent out that are just posting messages, and these messages are meant to influence public opinion or try and encourage some sentiment, and people think they're talking to humans when they're really not. But that is all for this presentation, and I hope you enjoyed. And if you have any insights that you'd like to share about the discussion statement or the question that I asked earlier, feel free to go ahead.
All right, thank you, Anthony. Very well done. I mean, I would say it's very scary how like AI is really good at at handling information from social media. So I guess nobody is safe from getting their information stolen. An example that you used of how AI benefits society was very well as well. Does anybody else have any examples of how like AI benefits our society?
It's very scary in general. I think that there's going to be a lot of questions as AI develops into what legal procedures have to go before companies are able to develop these AIs, just because of how powerful they are and how well they'll be able to manipulate people. It's almost like taking away their free will without them even knowing it.
Yeah. So John, you want to?
Yeah, I guess it would kind of depend on what you mean by like benefit society, because like AI can be used to keep retention rates higher in social media, and kind of like bring you to things that you engage with more. Whether that's a good thing or a bad thing, I think it could be argued both ways. But that's a way that AI can be used.
Pros and cons to everything. So I guess time will only tell how AI is gonna do in the future. Jerry, you want to go next?
Yeah, and like the same line of reasoning, I think that's something that I find really interesting is that like advances in AI, at least in something I'm interested in terms of like the field, while advancing video games towards something that benefits consumers, also at the same time can be used to like cycle people back in and get addicted to the game, and it can be used to engage them like further and further. And you see how advances in AI and kind of advances in the video game industry influence the design of games themselves so that they're more addictive and more engaging to people. So while it might make the game better and make it more, a better product for consumers, at the same time, it also has negative sides to it. And so AI kind of has that balance to it.
Yeah, you're absolutely right. We'll take our last participant, Michael.
Yeah, I just wanted to say it was like a really good presentation, and especially how you connected AI to basically the privacy and also the ethical aspect and ethical concerns. Because I think like before AI becomes more prominent, and especially with social media, it's becoming even more prominent nowadays. I think it's very important to sort out these ethical concerns before it becomes more prominent in society, and it's going to have more applications. So I think it's very important to sort these concerns out.
All right. Thank you guys so much for all your presentations. They were actually really good. Today was our first day, and I thought we saw a lot of good presentations, some good PowerPoints, and I really like how a lot of you incorporated questions in which you asked the class to really help with the discussions. And thank you guys so much for participating as well. It made the class a lot more fun. I know it's 3 hours and it's long and it's tough, but I feel like it was a lot better with everyone participating. We're gonna wrap up there. We do have 15 minutes left, so me and Arsen are gonna stay back for a bit in case anybody has questions they want to stay and they can ask. If not, thank you so much for coming. Have a good night. Yep. We have a couple questions. One in the chat, could you provide more info about the quiz? So the quiz is going to be an accumulative quiz that's going to be available in week 5 based on the recorded lecture content that the professor releases every Tuesday and other course content that she releases on Tuesday. So you guys want to make sure you guys go over that, make some good notes, study off of it, because that's what the quiz 5 is going to be about. Michael, if you want to ask your question.
Oh, I'm sorry, I forgot to put it down. I'm sorry.
Yeah, no worries, no worries. Another question in the chat. How is the participation mark calculated? Is it just the written feedback and discussions? Yeah, so primarily the participation is the written feedback you do in the discussions and submit it. What we did say at the beginning of the lecture is we are doing bonus marks for people who speak after the presentations and contribute like solid points to the discussion, things like that. So that's what will get you bonus marks, but the base participation mark comes from the discussions that the discussions and the feedback, that you post in the discussions page. Maha, do you want to ask your question?
I think I'll wait till everyone's asked theirs.
Okay, no worries. John?
Yeah, I was gonna ask for the topics that we're gonna be presenting on. I haven't presented yet, but can it be like the same or similar that we plan on to write our final report on? I just don't want to lock myself out of like a topic.
Arsen?
I would say it depends. I would say just select any topic, but don't select the one that you're presenting.
Just to be safe, we will get back to you on that. But you should be fine because the final report is pretty broad, so you have lots of leeway during which like you won't have to reuse information, I don't think.
Right, but like if I find a topic really interesting and I want to use it twice, that's why I'm asking if I'm allowed to. Otherwise, I just won't do it for the presentation, so I have it for the report.
No, for the final report, you have to pick from 4 questions that it asks. It's on the course outline if you don't know. So you have to pick from there, and if it's related to that, I guess it will be okay. But like, we'll double check with you.
The final report is structured versus this presentation. You can pick any topic. So if it does intertwine, then that's okay. But I don't think that you have the exact same topic based on the questions we give. Does that help or no?
Yeah, I mean, I'm not exactly pleased, but it does answer the question.
Okay. Or no, you want to wait till the end. Alham?
Yeah, sorry if you've covered this already, but how long do we have to submit our discussion posts?
You've got 1 week from today to submit.
Okay. All right. All right. Thanks.
Arslan, you want to take some questions?
Yeah, I'm just typing it in the chat.
Sorry, Hamid, you don't have your name, so I don't know your first name. Do you want to ask your question?
So there was this thing called special reflections. That's not a thing. You still have to submit the regular reflections you do every week, right? If you have a presentation that week, you still have to submit the reflection.
Yes.
Am I right?
Correct.
Okay.
Correct. The special reflection, it was worded poorly. It was just referring to your actual presentation content. Like, for example, when people presented today, they would like submit their slide deck in the tutorial presentation folder, and that's what they meant by special reflection. You're gonna stop the recording.